Hello guys, welcome back to a new video. So let me just change the view. Yes, I guess this is yeah. So yesterday we solved this problem and today we are going to solve this twosum problem. So in an interview, this is the pretty easiest problem an interview can ask. So let's solve this problem. Yeah, so given an array, there will be some integers in this nums array and there will be a target value. We have to return two indices whose values against those indices will be equal to the target sum. So the addition of those two indices values will be equal to the target. And there will be always be a one exact solution. Yeah, so this is the constraint. So here let's see this example. We have like output is 0 1 because this is 0 and this is 1. The value against this 0th index and the 1th index is 7 and 2, and the sum will be equals to 9. So that's why this is the answer. So let's solve this with the first approach. So we can use two for loops. We can at a time there will be one value. We can check all the other values against this value and we can sum. If we find a target, we will return those indices. So similarly we can check for this value, skipping we can run the loop from start to end, skipping this current value, and we can sum it and against this value, current value, and we can check. Let's see how we can route the code for this. So it will be like nums dot size. Let me stack it this way. Yes, it's working. So there will be a for loop and there will be another for loop j equals to that will also run from start to end, and we are going to check if nums I plus nums j equals to target, then we are going to return these two I and comma j indices. Otherwise we will return this empty. So this condition not gonna hit because there will always be one solution exist, but still we have to return something, so we are going to return an empty array. Yeah, and there is one check that we are missing, that we can't use same index for two times, so we have to skip for the current index when we are checking. So here let's suppose we are running two for loops for this condition. Let's suppose we are at this index 7 let's say, which is 0 and 1. Now when we are running the j loop for j, we have to skip this ith index because we cannot use the same value twice to get the sum. So that's why we have to add a check here, not here, here. If I equals to j, then continue. I guess this should work. Let's see. Yeah, this should be nums. Let me refresh it. Yes, this is working. Let's submit it and check for other cases as well. Yeah, so it's working. Now let's see what's the time complexity. So this for loop, it will run for n times, and this for loop also run for n time, but this is inside the other for loop. So the overall time complexity is going to be of n into n, so O of n square. So now here in this question it is written that can you come up with this algorithm that is less than O of n square. So there is a trade-off. We can use a cache here instead of this second loop. We can do it in O of n. We can use a cache. We can check if we have seen the value already. If we have already seen the value, we can return directly from there. So let's see how we are going to do. So let me just remove this. So just we have to run a loop. For that we need this nums dot size. We need a map, another map. So another map under the hood uses hash tables. So we will use this for our cache. So it will store an integer against an integer. So let's name it cache, and then let's run the for loop. Here we are going to check if our cache dot contains it will check if it contains target minus other half than the current value. If it already there, so we'll just simply so we will check if it contains or not. M dot cache dot end. So we will just directly return from here the I and the value at that. So we are storing these. We have to return the value. So this should be our cache and the target minus nums dot I. So this should be the value. Otherwise we will just update our cache with the latest value we have seen. So it will be like this. Yeah, and we are going to return empty, but this will not come, this case will not come. Let's see if it works or not. Yeah, so this is working for this case. Let's submit it. Yes, so this is working. Now let's see what's the time complexity and the memory complexity of this approach. So this is a cache, and so let's first see the time complexity. So this is an for loop that will run for n time. This find operation, since this is a hash map, so this will take O of 1. Yeah, so this for loop will run for O of n. So overall time complexity will be O of n, and the space complexity will be also O of n, since this cache can hold all the values up to the end. So this will also be our trade-off, since as compared to the O of n square approach where we are not storing any values. So yeah, so that's the solution. Now if you like the video, you can click on the like button and also consider subscribing. I am seeing like people are watching but not subscribing, so please consider subscribing. Just click on the button and also the bell icon. So we solved this today, and tomorrow we are going to solve this. So I will see you in the next video.